So I think that Joseph Smith proved the existence of God and also proved Christianity true.
Oh, I'm sorry. First off, I got to ask you, are you 18 and over?
Yeah, I'm 21.
Okay.
Born
It
2003.
sounded like your voice was older. I just wanted to make sure we're safe there.
Yeah, we're all good, don't worry.
So,
But
you think Joseph Smith proved it?
yeah,
Why,
because he
why specifically?
we know that he fulfilled many prophecies. He predicted his own unalivement because he was unalived by the Christians. He predicted that he would pass away within 5 years due to martyrship, and that prophecy did come true. He got unalived. We also know he talked about it a couple days before his unalivement. Um, so that, and he also predicted um, that the Civil War would start in South Carolina. And a few other like details about it that happened after he had passed away, after he got martyred by Christians.
What does that have to do with God's existence? Help me
I think
understand
that
that.
proves Christianity's true.
It proves Christianity.
Yeah.
It's an odd one from Joseph Smith, because we know Joseph Smith is essentially a con man who started a religion. But let's put that aside and just look at the more of the facts of the situation. So, because he predicted the Civil War, how many years before did you say roughly?
I think like 10 years.
10 years. I would imagine I'm not a real big student of history, at least not the 18th century history, but that's something that people could have seen coming. How did he predict it in terms of how was it in the Book of Mormon, or where was that
No, it wasn't
where
in the
was
Book of
that written
Mormon.
down?
He did a lot of preaching, right? He spent a lot of time spreading the good news, the truth. And he was basically telling all these people like things that would happen in the future. One of those things being like that the Civil War would start in South Carolina, and many other things regarding it. I actually have the screenshot, I think. But uh, yeah, he had predicted that. He had predicted his own unalivement, many things. Like, and it wasn't something people were like seeing coming, particularly from South Carolina at the time.
Well, we know people were after him because
Yeah.
again, he had conned people in the past. He had a bit of a history, so he
Hmm.
knew some people were after him as a
Hmm.
broad general rule, not specific plots or whatever.
Yeah.
Who
And
knows?
I like to reflect this with like Paul's story kind of, because we see in the Bible that Paul was out here unaliving Christians. He was doing a lot of bad things. Same with Matthew. He was a tax collector. I think when like the Holy Spirit, God calls on people and he says, "You will be the person that I change." I think it's very telling who he chooses because it's not always the person you expect. And I think that that really shows us like the truth of God because he repented um and turned of his ways.
So he chooses between Paul and Joseph Smith. He's essentially choosing the worst people to make the point.
Yeah, because he's showing how he can change their hearts, minds, and souls to be suited for the kingdom
Yeah.
of heaven.
How much do you know about early Mormon history?
Yeah, I know it's not very good.
Yeah.
But when we look at other churches in the surrounding area in the States, they were very similar. There's a lot of bad church history from all
Yeah.
denominations,
Yeah,
right?
I
And
agree. I agree. Catholicism. I mean, anytime you've got an expansionary religion, you're going
hmm
to have bad practices, if you will, people imposing on other
yeah.
people, particularly on Native Americans who were
hmm
considered quote unquote savages at the time. So
hmm
just because
hmm
they didn't live in a modern way. Uh,
hmm
Help me understand why the prophecy thing leads to a god, because to me it seems like if there's a prophecy that may imply a supernatural thing of some sort,
Yeah.
like
Yeah,
an
yeah. Hold on.
ESP kind of thing, but
Yeah,
it
I can link this to other
doesn't
things.
necessarily lead me to a deity belief.
Yeah, so I can like link this to other things, right? So when I'm pointing these things out, I'm just trying to explain to you that Joseph Smith is a prophet, right? He fulfilled prophecies. He is a prophet of God. So now we can move on to like the miracles that occurred, right? So we know that he translated the gold plates in a miraculous way through guidance from the Holy Spirit,
Okay,
right?
wait. Okay, now this is when you're going to have a real tougher problem here,
Right.
because he had a hat, right, and he had put stones in the hat, and
Yeah,
he
yeah.
was able to describe exactly how this worked. Did
hmm
he look into the hat? Did he?
hmm Yeah,
Uh,
yeah. I'll explain this because it's actually like a really common misconception among the Latter-day Saints, right? Because many people think that like, oh, these golden plates didn't exist. He just read it out of a hat. Like this was bogus. But we have many testimonies. We have 3 eyewitness testimonies of the plates. So like we have a lot of evidence that suggests these plates existed. But here's the other part. The or the language that was spoken on like or written on the tablets, we didn't like know, right? Because it was like we just didn't know, we couldn't see it. But Joseph Smith got direct guidance from God and translated it with the hat because he had like a seer's stone in there. And he used that to read and translate the Book of Mormon.
where
And
did
then
the stones come from?
I'm not sure.
So we don't know historically.
I think he got them from the angel Moroni, actually.
So that's kind of a circular argument then, because you're assuming that you believe that the angel existed to say
hmm
that the angel supplied the rocks, the stones.
Yeah, but we know the stones existed as well because
How do we
people.
know? We don't. Is it to my knowledge we don't have them currently, right?
No, we don't have them, but we have witnesses of people who saw these things. The reason we don't have these things is because God got angry with Joseph Smith because he had lost part of one of the books of Mormon, like one of the chapters. And yeah, he had to retranslate it, and it was like a whole thing. But God got mad at him and then took the plates from him after that.
Okay, you can see how, as an atheist, that I would find that to be unusually convenient in terms of a way
Yeah,
to
yeah.
explain why there were no stones.
Yeah, for sure. But here's the thing I want to like connect it to. I want to
Right.
connect it to like the prophecies that he did, which kind of shows me, right, that he's honest in his connection with like a higher being because he can't just like predict these things, right? Like a higher being had to have told him these things.
Okay, this is really. I'm kind of stunned that you believe all this stuff, Joseph
Why is
Smith,
that?
because it's the 21st century, and you're believing in reading hats, and what did you call the stones? I don't want to put the wrong words. Translation stones, seer stones,
Yeah, the
right?
seer stone.
The seer
But well,
stones.
you believe in like the Big Bang and evolution, right?
Well, we know evolution is true. We don't know what
No, we
caused the Big
don't.
Bang.
We don't know evolution is true.
On what basis are you saying that?
Because it's all a lie. Like they've just been like
Ah,
digging up these bones allegedly, but
okay.
we all know the truth. Like we all know God created us.
How long ago do you think this lie was begun in terms of evolution?
Probably for a really long time. Probably when people started to hate God, probably during like the women's
So,
suffrage
okay.
movement.
Whoa. Okay, so you're against women's suffrage. You're against scientists. My gosh, I got tangents to go down here. Are you against women voting, or are you against women having control over what it's decided for themselves and their families?
I'm against both because I think that the Bible makes it very clear that women are to like follow their husband's lead. It starts from Genesis to Revelation. So,
How were you raised? What
I was raised LDS.
LDS from? You've been in an LDS family from birth?
hmm
Yeah. Doesn't that seem odd to you in the 21st century that women are considered a subservient population?
No, I think it's like biologically a part of our nature.
Well, we know that there is no biological difference in terms of intellect between men and women.
Oh yeah, I wouldn't like go against that, right? But I think our intellect as women is supposed to be used to like help raise children and teach our children. I don't think we were meant to put our kids in public schools. Like I think homeschool is for the best.
Ooh. Wow, you're really jumping around here. Okay. So homeschools, you know why the religious right appreciates homeschool, don't you? And wants public vouchers to pay for homeschooling
Why?
because they don't want their kids to be, well, number one, they want to teach religion as part of the education, which
Yeah.
frankly, you don't have to do it in a homeschool. You can do it with the church activities. But they don't want them hearing, especially in these days, they don't want them hearing about LGBT practices, and they don't want them to hear about the science that contradicts the Bible, which would be the age of the earth and evolution, in particularly.
Well, we know the age of the earth is a lie.
How old do you think it is?
Definitely like 10,000 years old, maybe 12.
How do you get that?
Yeah, it's from the historical record called the Bible.
So you're talking about the accumulation of the dates throughout the
Mhm.
Bible, and it gives you an approximate
Mhm.
6 to 10,000 year age.
Mhm. Mhm.
Okay. Now we've got all the major scientists in the world know that the Earth is 4.5 billion years old, and we know the universe is 13.7 billion years old. So doesn't that make you feel a little bit peculiar that you're on a different page with those who are most educated in these fields?
I think that they're like paid by elites who want to like push people away from God.
Elites.
Yeah, like Elon Musk who claims to have gone to space.
Well, okay. So help me define elites then, because because there's elites in terms of power, and there's elites in terms of money. What what do you define elites as?
Probably people who have a lot of money and power. It tends to be men, but there are many women who are like using aborted fetuses as like face masks and stuff.
Okay. Oh my gosh. I am stunned. You're 21.
Yeah.
Oh my gosh, I'm stunned. Um, I I don't even if I. Jeez, where do I go with this? I mean, you're 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 living with information that is almost entirely untrue, and you've been
Well, can you
raised
prove it's
this way.
untrue? You're just like asserting it's true by saying like, oh well, it
Well,
just is this
me
way.
and 95% of scientists. I
Well,
mean, my
how do you
I'm
know?
assert
Wait.
what I'm asserting basically is their opinion, because I believe that the best information comes from people that are most highly educated in a particular field. So
Well, how do you know
I'm
that
not a
they're actually educated and that they haven't been
oh
fed propaganda?
gosh. So
I can
there's
confirm some of the physics behind what he's talking
so
about.
there's paranoia too then? I mean, seriously, give me something to hold on to that's a little more tethered to reality here.
Well, we can talk more about Joseph Smith if you want.
Okay. It's Various. What were you gonna say?
So I'm doing a master's in physics. I can confirm some of the like physics as far as like how we date the Earth and the universe and things like that.
Okay.
For example, there are these things called zirconium crystals. When they're forming, you cannot get lead to stay inside of this crystal. When it when it's forming, it's very very hot, and stuff is able to move throughout it freely. And lead cannot chemically bond with these zirconium crystals. If you try to force it in there, it will just physically push the lead out as it cools. So when zirconium crystals form, we know that there cannot be lead inside of it, but there can be uranium. And the thing about uranium is it decays at a rate that we know is nearly perfectly constant. There's a few things that can change the
Wait, it can
rate that you.
change?
Yeah, hold on. I'm explaining the context. There are a few things that can change the rate that uranium will decay at, but they are not events that occur on Earth naturally. They are
Give us
only
an
caused by
example, just so
humans.
we understand various what
So
type of thing can change the rate
have
of
some
decay.
uranium, if you have some uranium and you bombard it with a neutron uh, array,
Oh,
that can cause the uranium to decay faster. That's essentially what's going on in a uranium, boom boom.
so nothing released from the sun can change the rate of decay. Cosmic rays can't change the rate of decay at all.
Uh, it would have to be, first of all, like on the very surface of the Earth. Those cosmic rays would have to somehow make it through our atmosphere and our magnetic fields, which just really doesn't happen. And then that would only affect the uranium that's on the very surface of this
Okay.
crystal. It wouldn't be able to affect the uranium that's on the inside of it.
Okay. Okay. So it's for all intents and purposes, except for when it's on the surface, it is a constant rate of decay.
Well, even if it is on the surface, somehow these cosmic rays, um, well, there's really not neutrons inside of cosmic rays, but let's just say like some beam from somewhere else does contain neutrons. It it would have to first of all somehow make it through the Van Allen belts, then make it through our atmosphere, and then make it all the way down to the ground to the crystal. Well, without the neutrons decaying, which is basically impossible. Neutrons have an incredibly short half life
Van Allen
when they're
belts
not.
that's the magnetic field, right?
The Van Allen belts, yeah, they're like a result of the magnetic
Yeah.
field
Yeah. Okay.
up in
He's
high up in our
stuttering
atmosphere.
because he knows that I can debate this very easily.
Well, let him finish his point. Go ahead, Various.
Okay.
So neutrons have an incredibly short half-life. They decay almost as soon as they're not inside of a nucleus. So there's really not a way for them to get like from somewhere out in the cosmos down to the surface and bombard this crystal. And then even if they did, it would really only affect like a thin layer on the like outside surface of the crystal. It wouldn't be able to get to the interior region to like affect the decay of the uranium on the interior. So we know that like at the first formation of these crystals, it's going to be only uranium in there, if there is uranium at all, but there's not going to be any lead. And then
Okay.
we know the rate that uranium decays at very precisely. It's been measured thousands of times, and it's always a constant unless we do something synthetic to force it to go at a different rate.
Okay.
And when we take a lot of these crystals that we found out in nature, the like when we take the ratio of lead to uranium in it, many of them return, like millions of years. None of them are coming back with like 6,000 years.
You're talking about age of the Earth now.
Yeah.
Yeah, because the solar system. Oh, that is the age of the solar system, roughly. Yeah. Okay. So, JD, what did you have to respond to then?
Yeah, it's Judensky, and
You
it's
didn't.
easy to prove God's existence. This is a philosophical discussion, and we're just using our logic. And by the way, can I ask this question to the panel? What all exists in the natural world? Would you guys agree that it's matter and energy?
Panel.
Crickets.
Yeah, I would agree. Like anything which exists.
So what's
Well,
information?
we also have quantum fields, so I throw that in there
Well,
too.
quantum fields contain energy. Well, yeah.
Yeah.
Like not everything is energy. Everything has energy. Energy is a property of
Yes.
anything that
But
does
quantum,
exist.
quantum fields are not made of energy, right? They have energy, but they're not comprised of energy. I got that correct.
Yeah, energy is not like the building blocks
Yeah,
of things.
that's all I mean.
Things just like have this property that we call energy.
Yeah.
Energy is not really like a physical thing. It's more of like a numerical thing that shows up in calculations, I guess.
What's more physical than pressure mediation? All physics do is just try to describe everything in the process of seeking equilibrium. That's pressure mediation. It needs energy to do so. According to the second law of thermodynamics, it'll all be used up at some point. So it must need an origin point. Okay, if it needs an origin point, then the first law says matter cannot be created or destroyed. Where did it come from?
Oh,
That's a
so
question for you guys.
so
It
so
must need
the
something
whole like
supernatural, which exceeds natural laws and observations.
That is
so
quite the leap.
energy conservation isn't a thing in all of our theories. In thermodynamics, there's energy conservation, but when you move over to looking at the universe at a cosmological scale, you don't. I mean, you do use thermodynamics in the process, but like the more important theory that we would apply would be general relativity. And in general relativity, you do have local energy conservation, but you can't define global energy conservation because global energy isn't even a well-defined property within general relativity.
And when I think about this, I think that the conservation of energy is something that happens within the universe. Again, to my knowledge, because I'm not a physicist like
We
as you guys. But
can't say for certain if the universe is a closed system or not.
that's
Based on our observations of dark energy,
Yeah.
we
Either way.
actually think that the energy of the universe is increasing.
Well, that's
Either
kind
way,
of
it'd have to
that's
come.
kind of what I'm thinking of, because if in a sense that if you consider the beginning of the universe, or before the Big Bang, or what caused the Big Bang, that the thermodynamic laws only apply to the universe that we live in. If there is something before that generated that, that's a place that in time that, or
Ooh,
it's a place that
and
doesn't
and
necessarily carry those laws.
well, and
So the
also
laws
like
being,
each
hold
also
on. So
each
the
theory
laws
has
being that it's outside of space, time, or matter, right?
Possibly,
Believe,
possibly.
right? So we have an eternal, right? It doesn't follow the rules of time, right? So it's eternal and it's external, outside of this universe, and it's an
Possibly.
energetic, because that place it has to bring the energy in order to come into
No,
this
no, no,
dimension,
no.
right?
See, once you hit that border, you're right. It could be something that is eternal. It could be sort of a cosmological eternal, like a multiverse or a black hole from another multiverse or whatever. And then once you cross that border, you're no longer dealing with the same laws of physics.
and
It
also
does. The question is
even with
incoherent, or the argument's incoherent, because how did energy get here in the first place? So it must have come from an external source.
no, we don't know that for
It
certain.
could also
Have always been
it could also have been here um, eternally without
Well,
any.
if you say that, then it would violate the second law of thermodynamics, because all the energy is going to be used up and then entropy will increase. So that must mean it comes from a progression point, a
If it's
point of progression.
eternal, there never is a creation point. It just
I'm
always
sure.
existed.
Well,
I'm sure
and
various.
So there's no
E-
creation of energy
exactly.
involved.
and
I'm sure
and we
various
can't
could
really.
explain why our typical classical physics doesn't work the closer we get to Planck time.
Yeah,
It only
I've been
violates
trying to.
the first and second law of the
Oh my
natural
God,
world and the
JD,
natural
if you would let
laws.
me respond, I've been trying to say the same thing for like 5 minutes now.
Sorry, Various.
Thank you.
I was intervening. So go ahead.
So we also can't even apply like our current theories of thermodynamics to the like cosmological scale. Every theory is going to have its effective range where its predictions are accurate. Looking at Newtonian mechanics, it's accurate when we're like at a mass density that's significantly less than that of a black hole, and when the velocities involved are significantly slower than the speed of light. If you start getting anywhere near the speed of light, or have any objects with a mass density getting anywhere within the ballpark that of a black hole, Newtonian mechanics no longer works, and the predictions it makes are going to be completely wrong. Thermodynamics, we have an effective theory that works well within certain temperature ranges and at like certain scales, but we certainly don't have a like fully quantum theory of thermodynamics, or a theory of thermodynamics that's like fully compatible with our understanding of relativity and the fact that we can't like properly define a global energy.
Wow. This is
Basically,
news to me. This is
what you're
interesting.
what you're saying is that energy is here, but we don't know how it got here.
Yeah, so the cosmological constant that's in general relative in the Einstein field equations in general relativity, that actually allows the creation of energy within the universe. There's a
So
lot of
that
things
means that
there's a lot of things that are conserved under certain conditions but aren't conserved under other conditions. Like there's a lot of known processes. A lot of people are told, when they're going through their say like middle school and high school, that charge is always conserved. Like if you've got protons, neutrons, electrons, all these different things, they learned that charge is always conserved. The total amount of charge can't change. And that's like the kind of intro level of understanding, I suppose. But as you go up, you learn about something called charge parity violations, and that actually does allow for like the net charge in the system to change. There's also
so
a
were you
property called
talking
strangeness,
Is
and
that-
you're
strangeness
also
is,
filibustering.
Sorry.
I'm trying to explain context of how a lot of quantities that we say are conserved are really just kind of I'm trying to think of the word. It's not the full picture, like
Did you have a
these
direct
things that you're
question,
taught in high
JD?
school aren't necessarily true when you get to the higher level stuff.
That makes sense. Yeah.
Yeah, yeah. So by natural laws, energy cannot be created nor destroyed. That's fine. But then the second law of thermodynamics is entropy always increases. So the energy will be utilized to the point where it's no longer, and there's just entropy or just disorder, right? So that means
Well,
that it
the
had to come
the
from a certain origin point, and it
well,
have
the
to
second
progress from
law of
that point until
thermodynamics
it runs
doesn't.
out.
Yeah, so, but the thing is that energy can be created in GR. So even if like energy is getting used, more energy is getting created through GR. Also, the second law of thermodynamics isn't like a
What's
hard set in
GR?
stone. It cannot ever be
Is
violated.
GR, is
The
that
thing is, it's more of a statistical uh, thing than anything.
is GR
And
general
also,
relativity various?
yeah, yeah.
Okay. Sorry.
And also
Relativity is
the
incomplete
derivation.
at best.
Also, the derivation for the second law of thermodynamics makes the assumption that particles aren't correlated. If you do something to correlate particles, the second law of thermodynamics no longer holds.
What does that mean to correlate particles?
It's like a weaker form of entanglement.
There's a lot of ifs and theories, just conceptual, not
No,
scientific
these are things that
theories.
are experimentally confirmed. Theories are like the container that laws sit inside of.
So explain how energy and energy could come out of. Well, actually, we're talking about the second law specifically, right? In general
Talking
relativity,
about
with your premise. So
my
so we're
premise
talking
for
about
which thing.
how energy can create itself, pretty much. How's that not a
Yeah, due to
violation
the
of the first law?
cosmological constant that's in GR in the Einstein field equations. Tinfoil down in the comments
Equations.
actually can explain this better than I can. He's learned it a little more rigorously than I have.
By the way, sidebar various. I didn't run. They kicked me, buddy. You know,
Yo,
I never
All
run.
right. I mean, I'd be happy to explain the three baubles you were talking about.
Hey,
Yeah, how
He's
can
a
you have
flat
three
earther, by the way.
wobbles? Yeah,
Two of
try
those
to
wobbles are
to
actually in the same
poison the well.
direction. So two of those wobbles are actually in the same direction. It's just at two different time scales. One is describing the wobble in that direction over a short time scale, say days or months, and the other one, and that was the
Days or months? That's 433 days, bro.
I
Be
can't
specific.
remember the name of
That's
it,
the
but
Chandler wobble.
no, the Chandler wobble was the was orthogonal to that one. It's at 90 degrees to that one. Um,
It's the
the
wobble
precession
on
of
the axis that
so it was the
shares the
Chandler, the
precession of the
precession of the
equinox.
equinox, and what was the third?
That's natation. That happens 18.6
That one.
years.
So natation and the precession of the equinox are in the same direction. It's just
26,000
two different.
years.
It's just two different time scales, but they're in the same
You could
direction.
you can try to scale it down with time. You could try, but it all happens on one axis, so it's physically impossible.
Yes. So both of those are in the same direction. It's two different signals
It
happening
wouldn't
on the same
matter.
thing.
I actually just assumed it was the same direction, but how can it speed up and slow it down 26,000 years to the 18.6 years to the 433 days on the same axis?
The solar system is
That's
a
not physically
very
possible.
complex system. The Earth isn't the only body
That's
in it.
appeal to
There's
possibility.
what?
He said it's appeal
You're
to
trying to say something
possibility.
that's along the lines of like this could happen because we think
Oh, it's not
maybe
about
that's appeal to
possibility. These are
possibility.
things that have been calculated and like confirmed through simulations.
Math is descriptive, science explains. Now I want a physical representation of these three wobbles occurring on one axis at significantly different rates. Thank you.
So you guys are going to need to
Yes.
slow down a little bit on some of this lingo because it's going over my
We can
head.
slow it
And
down. It's just he can't answer it, but you know what I'm saying. But
I
let's go back
didn't
to the
hear anything
first
you
one
said,
because he wants to
so
use general relativity, and he's saying energy can be created
Mhm.
yeah.
because we
Absolutely can.
mapped it out with mathematics, and that
Yeah.
So it's
violates
not
the
just
first
that
law.
it's not that just that we like described mathematically how it could happen. Like general relativity is one of our most experimentally confirmed theories to date. We have never really seen violations to the postulates of general relativity.
so
Also, the laws of thermodynamics are only mathematically conformed. Like energy conservation itself comes from a mathematical theorem, right? So you saying that doesn't really mean anything per se.
how
It's all we have of the natural world.
how far
This is
should
the
we take that?
foundation.
Should we take that seriously than tinfoil? What would be more of a lay understanding of conservation of energy?
It only stems from a system's ability to conserve time symmetry. That's really all energy conservation is. Which time symmetry would just be if you have a system and those laws of physics that govern that system are consistent, meaning they don't vary with respect to time. What you notice is that energy necessarily must be conserved in that system, roughly.
If we have a system, we're talking about this world, this natural
Wait,
world that
wait,
we
wait, wait.
observe,
He
right?
asked, like, how should we understand in a layman understanding? There's always, like, assumptions that could be violated. That's why I said if. And be precise with what I say.
Why are we going by ifs?
Yeah, like
Because
also
I
what you
gave you
said.
I gave you like a place where it must specifically hold. There's assumptions that break this
Yeah.
this
And
necessity of time symmetry, like general relativity, for example.
you also don't have to describe your
Yes,
system as the
the
entire
if is in
universe if
general
you're just.
relativity.
You also don't have to
Oh,
describe your
other.
system as the entire universe if you're just trying to describe like the behavior of something here on Earth. You don't need to describe the entire universe in order to do that. You can take your system to just be the thing you're trying to study and the handful of things that are gonna like have the largest effect on it.
We don't have to, but we're discussing the origins of the universe, guys.
Why
Yeah,
suppose
I'm
there
just
was an
trying to
That's the
origin?
clarify
topic.
the meaning of what a system is.
Yes, and in this enclosed system, and we're talking about it could be any it could be outside the system, right? But then that mean that it would have to be eternal, but also where it came from has to be external because it would have to exist there for it to be here, right? And then it would have to be energetic. You'd have to bring the energy into this system. It'd have to be the primary mover. That's the
This is
source
really
for the
confusing.
Yes,
causal.
but
It's the
like
primary
global
mover.
energy isn't conserved in the
Hold on.
universe. The
Let me say
universe can just
this.
create its own energy.
You said
Mm,
if, then that's based off GR, right? Just a whole bunch of ifs, assumptions. There you
You
go.
mean
no,
if?
So we have a primary mover that's the
no,
source for the
No,
causal
GR is
mechanism.
extremely experimentally verified.
dude. Have you heard of something called the pound Ruckab experiment?
No, let's explore it.
Your brain
Really?
please.
Oh,
Tell us about that. I am not aware of this. So.
Yeah, so it was basically an experiment that like measured the gravitational like redshift of a given like particle in a gravitational field, basically roughly. This was experimentally verified as an actual thing that actually happens, and it was a prediction right out of GR. So if GR isn't reliable, then how do you explain that piece of data?
So what is that?
Can you
What
explain
is
the
that?
first point
What
of
is
that?
that? What does that do for us? What does that experiment teach us?
What do you mean?
So
I'm
the
where he is. I want to hear an explanation again. It kind of went past me.
yeah, what does the
Yeah,
experiment
so
teach us or imply?
Y- y- Yeah, so it was a specific test of GR, like the prediction of gravitational redshift. So gravitational redshift occurs because light moving in a gravitational field experiences a change in frequency due to that curvature being caused, right? So in the experiment, gamma rays were emitted from like an iron 57 nuclei at the top of a Harvard laboratory tower, and there's a detector at the bottom. And according to GR, as these gamma rays travel downwards, they moved into a stronger gravitational field, right? And they gained more energy, which causes their frequency to increase, which is blue shift, right? And conversely, if they're emitted from the bottom and measured at the top, they would lose energy to gravitational redshift. And we measured this shift, and it was use the how do you say it? The Mossberg effect, which allows for highly precise measurements of gamma ray absorption without recoil. So we can detect gravitational blue shift and redshift, which is a direct prediction of GR, and it was verified.
So tell me if I'm wrong, but if you can manipulate, or if it's somehow manipulated in the sky where it's charged and it makes it to where red shift looks like blue shift, wouldn't that mean that it's further and closer than it would, well, we thought it to be,
How would you
I
make
just
don't.
based off
redshift
its
look like blue
charge?
shift?
Yeah, I don't even know what that means. You
Eh,
you can't just make it look like this thing.
Yeah,
And like I don't know what that means because you can't make it look like a thing. It needs the thing needs to happen for the thing to happen.
Right, it's either gonna redshift or blue shift. You can't just like take something that's redshifted and make it blue shift right
Yeah, you
before it
can't
hits
make
your
it.
detector.
Yeah, like you can't do that without adding more things, which then you're outside of the experiment, right? This was just with their detector and like particles, right?
light particles.
Okay. Can I
You
steer
know
this?
you guys know the first foundation of GR, guys?
I mean, it's postulates.
No, it's the Lorentz contraction. That's where if you're in a moving vehicle, everything
Oh,
contracts.
That's
dude,
special relativity, not general
that's
relativity.
Okay.
And
I
that's
want to
not a
ask. I want to
postulate,
ask
that's a
something
result.
based on what JD said earlier. He said
Mhm.
that at the beginning of the universe, so at the basically at the point of the singularity, or crossing the point of the singularity, if there is a before, quote unquote, or other place, that energy has to cross over from a place it came from to be in this universe. That sounds possibly wrong to me. I wonder
yeah.
what you guys think about that concept.
It doesn't really
Energy was
sound.
created here as the alternative
Energy can be created. I don't know why you keep like saying that. Um, but I don't know what that means. Firstly, because like, what does he
from
mean
an
by
energy
energy?
source.
Yeah, what does he mean by energy? What does he mean by like external? Like, what does he mean by these terms? Like, these are really ambiguous terms that he's using.
Well, if we think
No, because we discussed the first and second law.
Wait, those are probabilistic laws, dude. They only hold in the thermodynamical limit. And the first law doesn't even define what energy is. It It's mostly like, hey, it can do this
Anything
thing.
outside of the natural world is just speculation or just supernatural.
So
That's
how does that
beyond
Yeah,
like
natural, guys.
how does that
exactly.
compete with
Anything
anything
outside
I
the
said?
natural world is speculative. So you're
Wait, how does that
speculating
compete
that
with
God
any?
exists.
Wait, JD, how does that compete with literally anything I said?
We can speculate until we actually form a really solid logical foundation, which is what I was going where I was going, guys.
We have a pretty good logical foundation.
All right, so matter energy cannot be created nor destroyed. Yeah.
Okay.
All right,
That's
so the
not
Yes, it
second
can.
true.
law is
It
entropy.
can. Yes, it
Once
can.
That's
all the
not true.
energy is used up, entropy
As
increases. That
Well,
means it
hold on,
comes
as
from
I
a
have
JD.
certain
explained
No,
to
origin
JD,
you,
you're
point.
not listening to what he said. The
have
energy
I
cannot be
as
mattered. It cannot be created or destroyed. That's
Hmm.
false. And we're trying
yeah,
to
it's
understand
it's
how it can
locally
be
true, but
false.
not globally true. And yeah,
Yeah. So
How
this
far is globally?
globally
globally
is
means
anywhere
like
where
the
you can
entire universe, the entire space-time manifold that our universe is in.
Okay.
basically a point where you can ignore the
Yeah.
universe's expansion.
Space time
That's
is a reification, guys.
Does that include singularities?
singularities don't
Yeah,
really
you would have to
exist.
include
So
everything.
Einstein
Singularities
stole space
are
time from
just
Henri Pacquiao.
mathematical things
they're
then, and not physical
they're more
things.
of like places where we have like properties, and those properties diverge into infinity. And we wouldn't say that in a property diverging is a physical thing that exists. It's just a problem with the theory's ability to predict at certain like energy densities.
Yeah, we've had other theories that had singularities within it, and then later theories came along and solved that. Classical electrodynamics developed by Maxwell that described,
Mhm.
electromagnetism, charges, and whatnot. That had a number of singularities within it that we never actually observed in experiments. But then quantum electrodynamics, developed by Feynman and a few others, like were able to come up with solutions to develop a new theory where those singularities, those infinities didn't show up and actually matched experimental results better.
Okay, so help me understand because I don't want to make making mistakes in my conversations because this
Mhm.
is at the limit of my energy. If we take the universe and run the clock backwards, we get
Mhm.
to an origin, right? We get to the Big Bang.
Um,
Correct?
Yeah.
what
I mean, we know
what
the initial expansion happened.
what do you suppose by origin? Do you mean like the observable universe or like the universe as a whole?
The universe as a whole.
That's more complicated. Not really per se.
Okay, well let me follow through on this logic and see how far we get, and you tell me where I'm wrong. I mean, because the observable universe is a subset of the whole universe, right? Because there's an edge that we cannot see past because it is expanding faster than the speed of light. Correct?
Roughly, yeah.
Roughly. So there is a part of the universe that we cannot see, but it's not like it's a border where the laws of physics change past that. It's just related to the speed of the expansion of space versus the speed of light.
Um, See,
Yeah,
like
the
I don't know.
information just hasn't reached us yet.
Yeah.
Yeah,
So, but
but like as
again, trying to wind the clock back to to when the Big Bang, the initial expansion happened. So
mhm.
so basically Planck time, right? So which is not time zero. It is just slightly after time zero, as we
Yeah.
talk about it colloquially. Is there
Well,
any
okay.
is there any um before, and I always use quotes on that we can logically think about in terms
No,
of
not
what
really.
initiated the Big Bang?
There's always
Not at this
inflation.
time.
There's always inflation, per se.
Well,
Which,
inflation is another way of describing the Big Bang because the Big Bang is a
uh,
rapid expansion. It's a rapid inflation compared to the inflation going
y-
on now, right?
so inflation is driven by a completely, or I say completely different. Roughly, from what we posit about inflation, it's driven by some sort of field, and whether like what type of field it is speculative. But it's driven by some field called the inflaton field, right? This is careful with the language, obviously, right? It's just before the Big Bang, there was this. The universe was, in some sense, there, and you had this extra strong behavior that kind of acts like extra strong like dark energy, and that energy got dumped into the, again, careful with the language, into the universe. And it's an explanation for how the universe got to that hot and dense state. It's not real, it's more of it's not really the Big Bang, it's an explanation to how the universe got to X state.
So that really is an implication that the universe always was then.
You
The fact that it was in a it was in a Planck times, it was at a certain state at Planck time, is just one feature of that time.
So it doesn't like definitively like show to that. You can hold to that, but this is like just what our model says, which would be the lambda CDM model. Like there is this inflation period, which our best model is currently agnostic on whether the universe had a beginning. So so if you want to hold to that, you could, right? Most cosmologists, or not most, but some do and some don't, right? You just gotta like
No,
understand like the art.
agnostic is fine. And I mean, and that's what when I try to describe it, again, my limited understanding, that's how I try to say is like, we don't know if there was a time zero. We don't know if
Oh
there was
yeah.
an eternity before, but it's a possibility it's a reasonable possibility in terms of possibility, just like I would consider, like a theist would consider the
Mhm.
God creator is a possibility in terms of an idea, a hypothesis.
When you posit some sort of eternity for the universe, you need to be careful with how you define it because you could run into BVG theorem problems. Um, in the sense that like you would need some sort of beginning for inflation, but not the universe. So you can hold that the universe is in some sense eternal, but inflation cannot be eternal.
Okay, fair enough. Fair enough.
You just need to be a little careful there, just a little bit.
Trying.
Be careful because in some sense it's eternal, but it would mean that it would have to violate the second law of thermodynamics. And I know you're
As
saying
we've
that
explained,
it's
the
only
second law only holds at certain scales.
holds to the scale
Also,
of what we experience in the natural world and what we ever
No,
experienced.
every theory
Not when we're
has an
talking about
effective range.
conceptual fallacies or refutation or
Every single
reifications.
theory has an effective range. We can't apply the second law of thermodynamics to the global universe. We can
wait,
only
you know
apply
what,
it to
JD?
locally closed systems.
You know what, JD? I'll grant you that. Let's say it's true. You can just posit that at the time of that, there was some sort of quantum vacuum effect that transitioned into like there was a lower phase transition that transitioned into a higher energy or higher entropy state. It's called a phase transition. Most internal model universes actually get away with that. They're called phase transitions. It's
Most
not a
what
defeater.
models? I want to hear what you're saying. Most what
Um,
models?
so the cyclical cosmology as a whole.
Is it phase transition would be similar to when the four forces break apart? Each of those is a phase transition,
Think of it
correct?
like when a system reaches maximum entropy, the system itself collapses on itself and sparks another Big Bang. That's one form of it. I'm
You're
not familiar.
saying that
I'm not familiar with
from
all of them, but I'm familiar with a fair amount.
so you're saying from entropy, which is random chaotic disorder, you could become you could
That's
bring
a
order out of
very
that.
like not good definition of entropy.
Well,
That
all that we
definition for
have here.
entropy works for certain systems, but not all. To like actually deal with entropy properly, you need to look at the mathematical definition of it.
All
Which
that we have here is energy and its application to
we don't
go
have
into
energy.
entropy.
We don't have energy. Energy is just a number. You don't hold numbers.
What is energy?
So, energy is just a system's ability to conserve time symmetry within itself, roughly.
Ability. So you're saying that at some point it can, but we don't experience that here, or we experience energy doing that all the time. I mean,
We
but in
don't
terms of
experience
can it?
energy. We experience ways that we characterize energy. That's mostly what we experience. Energy as itself is just a measure of something. Think of like how mass isn't a thing you hold, right? But like it characterizes things, or like
Yes, but
color.
this thing that we do characterize, its job is to turn into entropy at some point, right? It's using its energy, it's using itself to become entropy
No,
Okay.
entropy
Don't
is a
become
state.
in order.
entropy.
It is a state of just tending toward disorder. You don't become entropy.
Yeah, I would give a definition of entropy, but like I don't want to get into mathematics, right?
Yeah.
Yeah.
It's just a number
As I
of
understand, entropy is like the way Sean Carroll describes it is if there's a when you've got a system, we'll just call it a closed system for to keep it easier to think about. It's how many ways that system can be. If there are few ways, then your
yeah.
entropy is low. If there are many different ways it can be, then that entropy is high.
Yeah.
Right?
Yeah,
That's a very good
that's pretty good actually.
description.
Yeah.
Without like
It,
going into all the math, that's a very
Yeah.
good
So
description.
it's not like a collection of gaseous molecules become entropy. It's just the ones that are.
yeah, you can just say
Right.
entropy is like the number of microstates
There you go.
that
If you have a box
correspond
with
to a
some
given like correspond to a given macroscopic state per se.
Why
so
isn't that
box
always
or something.
why isn't that always consistent? I mean, if we have again, I'm sorry to be simplistic, but that's the limit of my knowledge. If I take a rock, for example, and it's made up of a matrix of atoms, well, let's just take a gas. Let's just give it full ability. Isn't there pretty much an infinite number of ways that could be collected and still have the same amount of pressure within the vessel that it's in? So wouldn't that be pretty much infinite
No, there'd be a finite number of arrangements that are possible.
based
Um,
on a Planck scale?
so because you have the trying to think of how to explain it in a way that
Here,
isn't going into.
I can give you like why the definition I just gave isn't always consistent, right? But to fit to your specific example, I would have to invoke some math, which I don't want to do right now, to be honest with you. It isn't always consistent because it mostly depends on the scale and level of detail being like considered.
Yeah.
So like to the definition I gave earlier, a microstate is defined by a complete specification of the system at like a particle level, which is really detailed, and typically it's impractical to measure for large systems. Where if you have like a macroscopic system, it's defined by a measurable quantity, so like temperature, pressure, which you can summarize the collective behavior of many particles, but you have to ignore the fine details of like individual positions and velocities, right? So this inconsistency arises when the boundary between the microscopic and macroscopic is unclear. So, like in a system that exhibits complex behavior, so think of like quantum effects or phase transitions, the way we define macroscopic might have to change depending on how we describe the system. So, in some cases, what is considered like a macroscopic property might still depend on macroscopic details, like in statistical mechanics, for example, where thermodynamical quantities are averages over microstates, which leads you to this blurred distinction. Additionally, the interpretation of energy, which is based on the number of accessible microstates, becomes less coherent in systems with complex or non-equilibrium dynamics, roughly.
I'm amazed at the level of knowledge you guys have. I'm very impressed. I gotta say.
A lot of work to accrue this
Honestly,
knowledge.
and beyond that, it amazes me when I think about what is our capacity as humans to know very complex things, and the fact that some people can get to the level of knowledge that you guys have and beyond is still quite stunning to me. Gives some hope for the years ahead. Also makes it tougher for kids going to school because there's just more to learn. It seems now.
Yeah, there's a lot.
Yeah.
JD, are you still gonna run like the thermodynamical arguments, or do I need to like explain why they don't really work?
Oh no, yeah, I'm going in and out. I'm like listening. Sorry, guys. Thermodynamics, as it appears, as it pertains to the natural world. I mean, what do we experience outside the natural world? We never have. They're just conceptual fallacies and unifications.
All of
Wait,
these
who's
things
making
are
that
part
claim?
of the natural world.
Now, GR is a part of the natural. It's how we understand the natural world.
I don't get
I
the
mean, he
word. I don't get
doesn't
the
even
word.
accept
Fa-
GR
No,
fa-
to
what's
begin
where
with,
where are you
anyways.
coming up with the word? Why are you coming up with the word fallacy, JD? I'm not catching that. What is the fallacy that you're referring to?
yeah, it's just this misleading arguments.
Also, this
It's
seems
the
like
refutation and its appeal to possibility.
yeah. So these are informal fallacies, right? Which on its face value doesn't really mean anything. Informal fallacies have distinctions between like logical fallacies, right? If you just pinpoint a single informal fallacy, it's not enough to just completely disregard what we're saying. You need to actually pinpoint why it's wrong to do so. Where if it's a logical fallacy, you can run that whatever we say can be thrown out, but not if it's informal. So can
It's a
you please?
logical fallacy.
No, it's an informal
Once,
fallacy. There's a difference. It has to do specifically with the structure of an argument.
yeah, that's why I said it's a reification fallacy. Because
Right.
once I start talking about things outside of this natural world, in quote unquote space, then we could talk about how those don't add up to to physics and how physics work. It just falls apart. It's bankrupt.
Everything
So
they
this
just
would
explained is in the natural world.
also
Everything.
again, you
That is
saying
science.
fallacy.
Science literally means explaining the natural world. That's what literally science means.
Yeah,
Yeah. Also
all the
again,
things we've
JD,
talked
you
about are
just
part of the
saying
natural world.
yeah, and again, just saying fallacy like it's X fallacy doesn't like mean much, right? You actually have to reason why it's wrong, especially if it's informal. So, which I'm fine with like letting you get away with that. But like, if we were to go to your claim that X physics doesn't line up with X physics, it's still wrong because there still needs to be reasonable correspondence between both theories. This is called the correspondence principle. If you have a more advanced theory that can explain better, it needs to reduce to the other theory that also has observational and experimental data confirming it. This is why,
Let me
like, we
give you a
still use
quick
classical E and M.
Let me give you a quick clean example. So when we were observing the sun moving out throughout the zodiacs in the sky, it was moving
What the
at a
fuck?
faster rate. So we decided to attribute that to a wobble on the reification of a globe model, and that was the 26,000 year tilt. That's the first wobble that everyone's familiar with. And then we saw the elliptic plane of the moon moving faster throughout the sky, and that's called natation. That's 18.6 years. That's another wobble that we're going to attribute to the globe reification. And that is just an observation in the sky from where we're looking at. And then we have the Chandler wobble. That's just, we're just looking at the stars, the speed of the stars moving faster throughout the sky. And that is, again, attributed to the globe reification model. And that's 433 days on the same axis, which isn't physically possible. And
So
on our
As
side,
I explained to you,
we
it's
say that all
two of
these
those are on the
celestials,
same
all these
direction.
luminaries in the
It's not three
sky.
different
Hold on,
axes.
hold on, hold on. All these
Wait.
celestials, all these luminaries in
Well,
the
you
sky
keep
are
on
just
completely
independent.
ignoring the arguments made and going back to statements you said before that we have told you are objectively incorrect, and you are stating them again like
Why
they
do you
are
have to
fact
cut off the
after we've
conclusion,
corrected you.
Darius? Why do you have to cut off
Because
the
you
conclusion?
keep on returning to statements that you know are infactual because we have told you that. So I don't know why you're bringing those things up
You have
again.
nothing here.
oh,
Wait,
also
JD
So
is
JD,
a
what
Smurf?
we posit,
yes, but wait,
Yeah, he's a
what
JD,
we
flat earther.
posit,
wait, JD. If you're gonna go off logic now, if two of your premises of your syllogism have been logically not valid, validated by a counter argument that thoroughly debunks them, then to go back to it is inherently problematic and doesn't actually do anything. You can just completely disregard everything you're saying if that happens, because you are begging the question firstly too. And one, you are also not considering any counter arguments. Can you explain how literally anything you just said corresponded to what I told you about 2 minutes ago?
yes, because you're saying that we have that example of which things work or supposedly can work but can't work physically. It doesn't work in physics to have three rates on one axis spinning
It
at
does.
processing at different rates on one axis.
It
So
does.
this
So in
is
26,000
completely
Not
unrelated to my
understanding it
claim.
doesn't mean it doesn't
18.6
work.
years and
Th-
433 days. But I'm just telling
This is
you
completely
how it
unrelated
works,
to
how
my
it doesn't
claim.
work.
You
This is
not
completely
understanding
I'm
it
just
unrelated.
telling
doesn't
you how
mean it
what you
doesn't
think
work.
works
This is
doesn't
completely
work.
unrelated to my
But
claim,
then I'm
JD.
also just telling you on our side, looking up at the stars, all motions and all luminaries in the sky are just independent. They move independently. So it doesn't mean that we have to attribute that to us moving and spinning and wobbling. It
Again,
just
this
means that
is
So
all
you
irrelevant
not
to my
observations in the
claim.
understanding
sky
how
are just
wobble
independent.
works means the Earth is flat?
Yeah, and
You don't
again,
understand how that
JD, this
works,
is really
apparently.
irrelevant to my claim.
I
So this
do.
just looks like dishonesty now.
It's
This is
absolutely relevant
it really
because
isn't, because nothing I said has anything to do with the globe model. In fact, for this argument, I'll just say the Earth's flat, and what I said still stands true. Can you again reason with what I said? Because nothing you said even addresses anything I said regarding the correspondence principle or nothing. So I'll grant you the Earth's flat, but can you explain that how this relates to anything I said?
we've never been outside of this Earth, right? So we can't
We
test
have.
space-time. There's no
Of course
proof of
we have.
this.
Of course we have.
Wait, JD, again, that doesn't correspond to anything I said. In the example I gave you, I didn't even use space-time. I used electromagnetism. So again, can you
I
entertain
must have
what I'm
not been
saying?
here for
Because I
that, brother. I
granted
told
you
you I
that
was
the
getting
Earth's
in and
flat,
out.
JD. So you got to give me some take back here. So
When did you
again, can
talk
you
about
demonstrate how
electromagnetism?
this
I didn't know.
can you show me how this responds to literally anything I said? Because twice you tried to do it, it was just complete straw man of what I said.
You mentioned electromagnetism and I didn't hear it. I mean, if I heard that, I'd be able to talk about that a little bit more.
Oh, really?
JD, the example I gave you was the correspondence principle, which you said that we have X physics and it doesn't line up with other physics. And I was like, it has to because of the correspondence principle. It's the reason we still have classical
No, it's not in
electromagnetism.
physics. That's a category error because you guys are claiming something about
Wait, what's the P and not P
the
with that?
spinning and the
Wait,
wobbling.
that's unrelated. What's the P and not P in that sentence I just made?
P and not P.
The law of non-contradiction. What's the contradiction I made within my statement that categorizes that as a category error?
It's a category error when you're claiming physics on observations. We're just
That's
we're just
So you're
seeing these
denying
independent
classical
luminaries in the
electromagnetism?
sky.
Wait, I want to make sure I'm hearing this right. You're denying classical electromagnetism?
No, I'm talking about what
Then your
I'm
your claim
talking
has no
about
meaning
looking
because that
at
was my
the
example.
stars and saying that you're attributing it to three wobbles on the Earth.
Yeah,
I
you're the
never
one
did.
that brought
That's
up
a
JD,
physical
stars, not
JD,
claim.
I
us.
granted that the Earth was flat just for this example. So again, you're not even listening to what I'm saying. So like, this is real dishonesty here. I granted you that the Earth's flat just for this conversation, and you're still like going back to that. This is like more
Yeah,
of a
you have
script and
not.
not really engaging with what I'm saying, which that's just dishonesty.
You have engaged
It's
with almost
contradictory
nothing
because
we
we're
have said
talking
this
about
entire
something
conversation.
outside of a closed system, but we have no idea what that is.
JD, what are you even responding to in regards to that?
I mean, you mentioned something about electromagnetic statics, and I'd like to hear more about that.
No, I said the reason we still have the correspondence principle is because it's for the same reason that we don't throw out classical electromagnetism and replace for quantum electrodynamics. It's because we have another theory, or the original theory per se, and it has some backing in observational and experimental data, but it runs into issues. If you want to talk about them, it's specifically the electrical field and classical electromagnetism that runs into singularities. And when we had quantum electrodynamics, it resolved those singularities and it extended the framework. That was my point of bringing that up, because you said we had X physics and it couldn't explain X thing with other physics. And I was like, that is not how physics works. If you have a model, you don't just get rid of the old model for the new one. There's no reason to do that.
Yeah, any
We're
new
still talking
theory we
about
come up with doesn't just supersede and get rid of the old theory. The new theory needs to reduce to the old theory in some sort of limiting case. Like GR, when you take the equations for GR, the Einstein field equations, and you take the limits where the velocities are significantly slower than the speed of light, and the energy density in your space is significantly less than that needed to create a black hole, Newton's equations are reproduced exactly.
so we're not talking about anything outside of this enclosed system, are we?
Right back to the script.
You can
No,
also do
and
the same
JD,
thing with quantum electrodynamics. If you take QED and you take certain limiting cases, you recover Maxwell's classical electrodynamics right out of it.
Okay, cool. So we're still talking about everything inside this closed system in this observable natural
Not a
world.
closed system.
So this is not a closed system.
It's not.
Okay, so this is a system. This is the natural world.
Well, that was enlightening.
I can't believe I granted that the Earth was flat for that guy. I just feel disgusting now.
Take that back.
Tinfoil, did you see Nathan have to run from me yesterday? It was hilarious.
Honestly, Various, I haven't been much in the flat earth community anymore. The total
Yeah.
dim rods are wearing me out.
Yeah. He came up on Pope's live, and he immediately, did what he does, where he tries to take over the panel and overtalk everyone and run his script. And
Yeah.
almost immediately he claimed he understands our models better than us, and I just, oh, really, like as loud as I could. And Pope just started laughing, dropped everyone off the panel except me and him. I was like, okay, cool. Since you understand our models than us, let's say we have a Lagrangian describing an electron, and this Lagrangian happens to be time invariant. What does this tell us about the electron? And then he spent 10 minutes waffling, trying to redirect the conversation, and I just kept circling back, like, no, trying to do his debate tactics that he always does, and I just wasn't letting him work. I was like, no, you claimed you know our stuff better than us. This is a thing from our models. Like, why can't you answer it? And then after like 15 minutes, he just dropped without saying anything. It was great.
That's cute. That's funny. See, I love doing that to people now. Oh, he's gone.
Right.
He's
Like,
a runner.
if that's not even a super hard question, concept, like, you do need to have some education in the topic to know it, but it's purely conceptual. If you know the answer, you know instantly. You don't have to think about it.
Mhm.
Okay,
He could
guys.
just.
Go ahead.
Oh, I was gonna say he could have just said like the energy is conserved within that electron, and that would have been fine.
Yeah. I told
Which
him,
is
like, you only need 3 words to answer this.
yeah,
Really, not even 3. You could cut it down to 2.
yeah. You could just say energy conserved.
Well, energies.
Oh yeah,
Subtract
energy.
the.
Sorry,
Yeah.
they have
So
had intergalactic
is
technology.
there a consensus? Anything near a consensus on how the universe, how the Big Bang initiated?
No.
Not really. Like I can only think of inflation, which is accepted now, pretty much, despite no evidence, like no empirical evidence of it. It made some predictions on how like galaxies are like spread out, and we observed some predictions of that. There's also like some fringe arguments against it, but usually those are settled out if you modify inflation a little bit.
So are you talking
But
about
the only
inflation after or inflation, hyperinflation
before.
as part of the Big Bang process itself?
So like the model I'm referring to is colloquially what you know as the Big Bang. It's just the Latin CDI model, and before it, or again, I'm trying to be careful with the language. Before, dude, I don't know how else I can word this. Before the universe's expansion, there was another thing before it, and the reason that we have this is so we can level with some problems that the original Big Bang theory has, and an explanation for how the universe got to this state. Because if you just take the normal model of the Big Bang when it was originally proposed, it already presupposes that there is something there. It's more of the aftermath of the bang and not really the bang itself, if you want to characterize it like that. So with inflation, the hope was that we can resolve some of these problems. One of them was something called the flatness problem, I believe, where the universe is like flat, right, as opposed to like curved. Um, so
Think.
inflation can reason with that.
I think we should explain flat. You
Looks,
look.
yeah,
You had a look on your face that to me was confused.
yeah.
So
I
Well,
gotta run.
it's
Thanks for having me up, Phil.
okay. Take care. Yeah,
so
flat in 4 dimensions. You're talking about, right?
yeah. So like picture a globe. If you try to make 2 parallel lines on a globe, the distance between those 2 parallel lines will change. That's because you have a straight line happening on a curved space. If you have like a flat desk, though, you make 2 parallel lines, that distance between them will absolutely never change.
Yeah.
Well, at least as far as we could tell. So space-time being flat would be the same idea. You make 2 parallel lines and you send them off to infinity. If space-time is flat, they'll never change distance. They won't diverge, they won't converge, just that distance is preserved. If space-time isn't flat, there will be either a diverging or a converging based on the geometry of the space-time.
It's hard to imagine, but yeah. So you're describing a 4D universe in 2 dimensions by reducing it to 2D, right? When you're doing
Well,
that,
since they're parallel, we can cut it down to 2 plus 1 instead of 3 plus 1, the plus 1 indicating there's time.
yeah.
But since they're parallel by like construction, similar to like if we're doing it on a table, we don't need to worry about like what's above the table and below the table.
Right.
We've reduced the problem to 2D. But yeah, we would need to do like a 2 plus 1 manifold in order to like properly analyze
Yeah,
the
and
behavior of these rays.
yeah, so inflation was just posited I believe by Mr. Alan Guth and some other people
Yeah.
to basically solve some of these problems, which the way inflation solved Linus' problem. It just says that after a little second of the Big Bang, the universe underwent an exponential expansion. So think of like, say we have the universe, right? And its scale factor, which just describes how distances like between objects in the universe change over time, right? If you imagine that that doubles every 1 second, right? So if t equals 0, the size of the universe is 1 unit. Then after 1 second, it's 2 units. After 2, it's 4, and then so on, right? So it posits that.
To my understanding, the fluctuation of the cosmic, when it was expanding, the universe became geometry flat. Is that correct?
Spatially, yeah.
So do we know why the expansion rate was so rapid early on, and why it is so well? It seems to have been more stable for a long time, and now again it is speeding up. We know why there's a variation in the expansion rates?
So the early high expansion rate, that would be inflation, right? So it would have been driven by field. That field is not really well known. There's a lot of mysteries with it. And as far as like today, there is some data suggesting that maybe dark energy is slowing down. It's weakening.
Dark energy is not in the EMF spectrum, so is dark matter. I mean,
And the sky is
it's
also
just
Yeah,
blue.
called
by definition.
it's just
And,
called
and,
missing mass. I mean, what are we talking about here? Just a lot of ifs and
and like the
assumptions.
sky's blue. The sky's blue, JD.
Before we dive back down into arguing nonsense, foil. I just learned of something. I'm sure have you heard of the Sphaleron process?
No.
No, I haven't.
So at all scales that we have currently observed, hadron number is conserved. Particular example of hadrons that most people are going to be familiar with are protons and neutrons. There are a bunch of other hadrons, but those are, the two people are most familiar with. And then there's these thing called leptons. That's like your electrons and your neutrinos. At all scales that we have currently observed, hadron number and lepton numbers are conserved. The Sphaleron process is a direct result of electroweak theory, where electromagnetism and the weak nuclear force unite into a single entity at high enough energy scales. And so the Sphaleron process, although it hasn't been observed, it is a direct result of a theory that has a lot of experimental verification. So far, we haven't been able to observe the Sphaleron process simply due to the size of our experiments. None of them create enough energy density for the Sphaleron process to even happen. So the fact we haven't observed it isn't evidence against it. It's just,
Oh.
we can't do it
Oh,
yet.
that would refer to.
But the proposed future circular collider at CERN would be at high enough energy to potentially cause the Sphaleron process. If we could replicate the Sphaleron process, that would explain why we have electrons and why we have hadrons.
Wait, that would also be
Wait, not
helpful
hadron.
in baryogenesis.
Baryon number, not hadron number.
Yeah, that'd be useful in like baryogenesis.
Yo, since this is a atheist discussion, let's bring it back to matter and energy in the natural world.
Okay.
So
Yeah, this is natural world we were talking about.
So yeah, we have matter and energy, right? That's the two tools that build up our reality, right?
And it's not globally conserved.
Sure. But what's information if that's the only thing that's here, matter and energy?
Wait, what's information? Information is just anything characterized by a body of knowledge.
Yeah. So that's neither matter
Everything
or
has
energy.
information. I mean, you take
Yeah.
any chunk of space or earth or rock or whatever, and there's information in terms of what's the order of the arrangements of it. That's information. It's more a
Yes,
question
I
of
think
what information is more functionally productive than other types of information.
I think he is trying to ask us about information more in like the thermodynamical sense by looking at like the Shannon entropy. Is that what you're asking?
me? I didn't ask a question about entropy. I just asked a question about information.
Okay, so in what sense are you trying to ask about information then?
Yeah, it's neither matter or energy, so you guys got a problem, right?
No, why is there a
We
problem?
can talk about information in thermodynamics. We do have like physical theories of information.
Also,
Is
you
it not as
can
it
just say,
applies or just on its face? We're not just like throwing out the definition of information and just saying, well, it works here or there in the natural world. We're saying, why is it here in the first
JD,
place?
this is really
Like I
confused. Like
said, we
energy
do have
itself.
physical theories of information.
If you have
Yeah,
existence, you have information.
yeah,
Right?
JD, you can hold
By
information.
definition.
You can hold an information like an abstract concept, which energy itself, in some sense, is an abstract concept. It just refers to how we characterize interactions of systems, right? You can hold to it, knowledge being an abstract concept as well. There's really no issue here. This is just more of a confused point.
No, that's fine because I'm glad that you said energy is can be an abstract concept because that ties in with my argument. Energy and information would have to create what we see in this natural world or what matters to us, right? All the matter around us, energy, information first, then the matter.
No, 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 no. Energy, right, just refers to the stuff. Matter is the stuff, roughly speaking. Mostly for
Yeah, it
amounts, but
refers
neither
to,
here nor
but
there.
also it's the buildup, and in DNA, it's information that is the
Why are we jumping
software, but
topics?
also no, we're still on the same topic. Information is in DNA, it's the software, and also it's the programmer that creates the programs for the software. That's all encoded in our DNA. We have information, and it acts on the matter that we have, and that's the only way that's possible, right?
Are you trying to argue that like God had to make us because DNA contains information? Is that your argument?
Yeah,
Oh,
absolutely, and it's completely sound.
Yeah, I mean,
oh,
we
brother.
have, like I said, we do have physical theories of information that explain like how information comes about within physical systems.
Yeah. Also,
Theories.
Because the
JD, how are
universe,
you? Wait, JD, how are you contrasting this with naturalistic explanations? Like, let's say, like, we throw out like everything else. Everything else is bunk. How are you distincting between what your quote unquote creator did as opposed to naturalism?
Well, naturalism is just observations of the natural world, and that's just
That's
energy
not
and
entirely true.
matter.
That's not entirely true. It refers to
Well,
systems being able to
it's close enough.
not really, because then you're mischaracterizing what I'm asking. What I'm asking is
I
Go
feel
ahead,
like
go ahead,
you already
give your definition, Tinfoil, of naturalism.
yeah. So naturalism would just be like the absence of whatever creator you posit as a proposed mechanism for how the universe functions. So how are you
I feel like
You
distinguishing
you're
can't
between the two?
you can't say creator, bro. That's not in your toolbox in this argument, bro. You
What are you
can't say
talking about?
creator.
Wait, what are you talking about?
That's my position to say creator, bro.
That's
we're
not how
saying
definitions
there's
work. So like
absence of
your
one.
definition, yeah, your definition of whatever God is would just be some sort of creator, right? So my definition would be anything that is not that definition. That's
You just said
like
creator. You just
right
said
in your
creator.
view, and your view, not my view. I'm using your
Yeah,
view.
our view is that there is an absence of a creator. We can say that. do you believe that there's an absence of unicorns and magic teapots?
Oh, okay, I must have misheard. It's fine.
Like you can still say unicorn. I feel like you're trying to
Yes, but
circle. I feel like in some way you're trying to circle to like the second law of thermodynamics says evolution isn't possible. It always
And I
ends up
will,
coming to
yeah.
that. Yeah. Okay, so but again,
No,
like
I'm not. I'm
the
not
second law of
disproving
thermodynamics.
evolution.
Yeah. Huh?
Evolution helps our argument because all these different
What?
animals needed needed that ability within them to adapt. So it had to come from an intelligent designer.
No, there just needed to be an energy input so that entropy could decrease.
Energy, information, in
Yeah,
order for
so
this
because the
these
Earth isn't a closed
processes to
system,
occur
because the Earth
between
isn't a closed system,
animals.
the entropy of the Earth can decrease.
So, do you guys think that we accidentally came to this universe? Is that what you guys think?
I don't know
There was
what
no
that statement
accident.
means.
I mean,
I don't know
even
what.
if it's an
Hold on.
accident, that's just information, kind of just like it's still ordered. Even if it's an accident, it's using a metaphysical application, thought.
That's not metaphysical at all, but that's fine. So like the like I don't know what that means temporally. Like when you say accident and before, like I don't know what that means in the context of referring to how we got here. Like
So,
you're referring
how
to
did we
temporal
got here, according to your understanding?
So to me, I just posit the universe is eternal. So I would just say how we got here. It was
Wow,
a
it,
long process.
eternal. But when you say eternal,
Hmm.
eternal, it means something that does not have a beginning. But the universe had a beginning.
Does it?
There was a beginning to inflation, but we don't know like
Yeah, we don't know that.
if there was a quote unquote before or if the universe goes back forever. All we can confirm is that there was a beginning to inflation.
But that means
There is a
if
beginning
something
in this
goes
eternal
infinite,
universe.
Wait, hold on, JD.
but if something goes infinite, it means that we will not existed. For
According to
How
what?
instance,
so?
if I give an example, is let's say I'm a soldier and I have to ask my superior for this order. He has to ask his superior, and he has to ask his superior. It has to stop. The chain of command has to stop somewhere. If not,
Yeah,
I'm not gonna get
you're
the order
describing
to
a
do something.
finite process.
Yes,
You're describing what is already known to be a finite process. We're talking about like the beginning, quote unquote, beginning of the universe. We don't know if that's a finite or infinite process. We don't know if like inflation began, like a millisecond after the beginning of the universe, or we don't know if there was an infinite amount of time before inflation started.
Hmm.
Yeah, and honestly,
There's
I
like
know
no
that
evidence in
the
either
theist
direction.
argument is that God has to be a beginning, but then you're begging the question there too, because the idea that God can exist eternally, but a universe can't exist eternally makes no sense. You arguing
uh,
against the existence of an eternal
uh,
being, just this if you're arguing against the existence of an eternal universe.
yeah. According to my opinion or of understanding, I think that a creator or God or supreme being, if he exists outside of the universe. Because in order to be to be an eternal being, you don't follow the aspect of time. Therefore, you don't you don't follow the universe. Understand?
How can something that exists outside time do anything? There are no moments to do, including create.
That's what it means, eternal.
How
Because
can
What
something which has no
we're
time
arguing the same
do
point,
anything?
right? We're saying the universe is eternal, and then we're asking that question to the same
No,
question in
but
different like
yeah,
references.
well,
if the universe
Fee's
is
argument
eternal,
was that God doesn't experience time.
yes,
In order to create something, you do need to experience time.
Right.
If he existed forever,
uh
then he would be and created the universe. He would still be experiencing time under that definition of him.
Yeah.
yes.
That's essentially what I'm saying from the other side, from the other direction is if he exists outside time, that there is no time to make anything. You can't do anything but exist in a static manner.
But that means eternalness,
That means
isn't
what?
it? That doesn't that describe that he's eternal?
If he is eternal and
Yes.
outside of time, he does not experience time, he can do nothing but exist. Because there are no moments, there is no change from 1 second to the next because there are no seconds.
Yeah, but that's
So you
hasn't that
lose the whole concept. If you conceive of an eternal God, you lose the concept of a thing that can create.
so? To my understanding, what you're saying is, if if God does not follow under the, I don't understand.
Okay.
It's,
If
it's
I mean, it's the difference between following some logic and just making up rules by magic, by saying God can break the rules of time or something like that. If you're going to make a
no.
logical argument about a being that exists outside of time, the
Yes.
only thing that being can do is exist statically.
Time is just a
That's the
concept
logic
that
of it.
time is just a concept that humans move in order to. It just represents passing and change for us. It has nothing to do with 4D space time.
No, it
It has
doesn't.
no, it, we never have any experiences
But
that any experiments that manipulate time.
Oh,
but
yes,
but
there
So
are.
JD, if you said that to a B theorist, like they would completely like throw up. To a B theorist, the passage of time isn't a real, like, it's just a like illusionary perception problem, and there is no distinction between past, present, or future, right?
We also
So like
can manipulate time in experiments
Yeah,
due
yeah,
to
that's
you
special
also
and
fine.
can
general
do that.
relativity.
That's fine. I'm just saying it's conceptual. It's not like you can
No,
manipulate like it's physical.
no, we can physically manipulate time due to special and general relativity. We actually have to account for effects from both special and relativity in GPS satellites. Otherwise, their error would be massive. If we didn't, the moment that you started using GPS, then the error would almost instantaneously be 20 meters, if I remember right, and it would grow over time.
They tried to do.
doesn't that just
They
mean
tried
that you're
to.
experiencing but not changing it?
No, they tried
Huh?
do the what's it called? It's called like the clocks, the seismic or atoms. They try to use
The
the
cesium
time,
clocks.
the
Yeah, and
cesium
they
clocks.
found that they actually did go through time dilation. We also know time dilation happens due to the amount of muons that we observe at the top of the atmosphere versus the bottom. If time dilation wasn't occurring, we would have way less muons at the bottom of at ground level than high up in the atmosphere. We also know that time dilation is happening due to high energy colliders. Particles exist in them for not the amount of time we would predict if time dilation wasn't occurring, but exist for precisely the amount of time that we predict using time dilation.
For the first point, they put the cesium clocks in planes, and they went at went in different directions, and they had to manipulate the time of the clocks in order for them to match their predictions, and it didn't work. It wasn't even close to uh, their predictions.
That's
So
not
I
true
mean
at
that's
all.
just a
They did match theoretical predictions.
what's his name, Ron Hatch, or is it John Hatch? Yeah. Um, there's a lot to do with that one, but shoot, it's just like once you dive down the rabbit hole on these discussions, flat versus globe, you kind of learn everything about
All right,
everything.
so a
Can
reenactment of the original experiment by National Physical Laboratory took place in 1996 on the 25th anniversary of the original experiment, using more precise atomic clocks than during the first experiment, during a flight from London to Washington, D.C., and back again. The results were verified to a higher degree of accuracy. A gain of 39 plus or minus 2 nanoseconds was observed, compared to a relativistic prediction of 39.8 nanoseconds.
How did
So the
cesium clocks work?
predicted was 39.8, the measured was 39, and the error bars were only plus or minus 2.
How do cesium clocks work? Do you know?
It looks at, I'm trying to remember, it has to do with the precession of the cesium atom, if I remember right.
Well, don't they bounce the signal off one cesium atom to another one, and they get a reverberation? And
That
does that sound familiar?
uses the frequency of light absorbed and emitted by the cesium atoms to keep time. So they evaporate the cesium atoms into a vacuum chamber. Infrared lasers cool the atoms to near absolute zero. Then 2 lasers shoot the atoms through a microwave-filled cavity. Atoms pass through the microwave cavity, which is tuned to the natural resonant frequency of cesium. The atoms are detected at the other end of the tube, and the number of atoms that end up in a higher energy state is counted. The microwave frequency is adjusted until the correct number of atoms end up in the higher energy state. And then the time it takes to count the microwave cycles is equal to 1 second. They are by far our most precise clocks ever made. The best cesium clocks are expected to be off by less than 1 second after over 50 million years.
So how do they manipulate this this cesium clock? Can you explain in layman terms, like manipulate time using this cesium clock?
Yeah, so they flew the clock in a plane, and due to effects from both GR and SR, there was time dilation. In special relativity, you get time dilation due to, if we have some ground-based observer and then the plane, due to the relative velocity between these 2 reference frames, that causes time dilation due to special relativity. And then due to the plane being at a higher altitude, it's going to be in a weaker gravitational field. That's going to cause time dilation due to general relativity. And then I think beyond just the weaker gravitational field, I'm trying to remember. No. Since they flew there and back, we wouldn't need to account for the Sagnac effect.
So, and just for the audience, so just so we all know, time dilation is basically the idea that, if because speed equals distance over time, right? And they measured the Lorentz contraction off of the Michelson-Morley experiment. That's where they kind of put that in there. It's basically you can't
Michelson
tell.
Morley experiment wasn't.
No. That came from Maxwell's equations, firstly. Lorentz found a way to make this. Well, his equations predicted that in some sense there needs to be some frame where the speed of light is consistent within observers. This came
Yeah.
from Lorentz, like specifically after Maxwell published his equations, and this was completely unrelated. But after the Michelson-Morley, there was more push to drive for it because it didn't work with Newtonian mechanics.
Right, but let me just explain that. So, I mean, they had a fringe, what's it called? A fringe shift of like less than one, like the length of a human hair. It's like 1/500th the length of a human hair, and that little fringe
You're
shift, they
talking
needed the
about
Lorentz
in
contraction.
the. Are you talking about in the Michelson-Morley experiment?
Yeah, but I'm just explaining what
Okay.
Lorentz contraction is. So they needed that little small measurement, 1/5000th the length of a human hair, in order to make up for that fringe shift. And basically, the Lorentz contraction is you can't tell, you can't measure a window with a measuring stick of any sort. And because if you're in motion, it's
Yes,
going to
you
shrink.
can.
If you're in
So
motion,
no, in your reference frame, the object of things, or the size of things don't change. It's in another
exactly.
reference frame where, like, if I were moving towards you at some extreme speed, I would see your length contract and you would see my length contract, but to each of us, our own size would not be changing.
Exactly. So if you're in that train, all of us together in that train, we try to measure this window. The ruler's going to shrink in, the window's going to shrink in, all of us are going to shrink in. We cannot
No,
measure
no,
that
no, no.
window.
That's not true at all. The people in the train, they're not experiencing any length contraction.
I
They can
know
sit
in
there
terms
and
of the
measure the
reference
window just
frame
fine. Hold on, hold on. So
outside
it
of the
is
reference frame.
the external reference frame. When they look at the train, the width of the windows would be shrinking, but you can still like you can still measure it. What you need to do is look at it like you basically perform Lorentz transforms on x and t, and you measure the distance at a fixed point in time. If you wanted to recover like what the actual like width of that window is um, in the train's reference frame, you can do the calculations to get back to that.
Yeah, you can do the calculations for that. But
Yeah,
then
so like
also,
visually, we would see it shorter, but like we can then do the math to figure out what the actual width of that window is in the train's reference frame.
visually, we'll see it shorter.
Yeah, we will like when we look at it with our eyes, it will look shorter to us.
But then we could do calculations to say, oh no, this is actually 12 inches.
Yeah, like based on its velocity and its angle to us and all of that, we can do that.
And this doesn't apply in this example of the train. That's kind of like far from where this math would apply, right?
No, Lorentz transformations apply to, any objects in motion in a flat spacetime.
This is where I have to bring up the whole plane thing because this is exactly what I was talking about in terms of them trying to manipulate the seismic clocks in order to get their prediction according to the Lorentz contraction theories, Einstein's theory of relativity, and all that stuff. So,
Well, it's not
I mean,
just
it's a lot to
length
get
contraction,
into.
it's time dilation too. We could
Yeah, time
go into the
dilation, but
math.
that
If
that's
you
that's
don't
the
do the
same
math,
thing.
like none of it actually makes sense. The math is
Well,
explicitly required to do
well, of course,
these
It's
and
things.
that's
relatively
kind of where you
simple
guys
too to work
run into
through.
trouble. That's where you guys run into
Run
trouble
into
because
trouble? How do we run into trouble with the math? Please explain.
math
They
is
were
just a
derived
descriptor.
only using the math. It's
Yeah,
even
math is
funnier.
descriptive. It describes reality.
This is like getting upset that people use colors to describe like frequencies of given things.
You realize like it's the same theories that people use to like build your phone and your computer and the internet and cell phone towers and microwaves and your car and literally all of modern technology.
Yeah, which if you deny like that, then like the transistor in your phone using like the electron tunneling also doesn't work.
Well, you could apply math where it doesn't really need. Like for instance, you could map out a sphere on a table. You can make a table into a sphere by just mapping it out with a couple of um, vertical objects on the table. You can map it out mathematically to make based off casting the shadow of it. You can make it a sphere. The table is sphere.
So is this proof against what we're saying
What?
or for it? Because this just seems like this is proof that math is a really good description of the world, especially with the axioms we've set.
No, if you can manipulate like reality and say this is a sphere when it's not, when it's just a table, but you can map it out mathematically, that means that it could just be used in different ways
Okay.
that aren't analogous to reality.
Okay,
It doesn't
wait.
reflect
So
The
reality
problem is that
actually.
when we
wait,
do
wait,
this
wait, wait, wait.
math and try to make predictions, we get these predictions correct, like 99.9% of the time. Like,
You know what,
w-
JD? Like, let me grant you that. manipulate the math in your phone right now to work differently, and the phone still work. Better yet,
That's
do that for your car. Do that for your
Right.
car.
If that were the case, I would just manipulate the math
I'll
in
give
my
you guys
computer to have more RAM.
a better example. We could make an equation for like the way Superman would fly through the sky. We could use math.
That's just using kinematics. That's not really making new
Yeah,
equations.
like
That's literally like anything that flies. They follow relatively the same aerodynamical and kinematic like
yeah,
processes.
all you're arguing
You guys don't
about
know what
is that
Superman
math
is
is an
though, right?
abstraction, and we can describe things that aren't necessarily true in reality. The thing is, when we're talking about special and general relativity, and we make predictions using this math, and then we go out and test an experiment against that prediction, the experiments come out to exactly what the predictions say they will every time.
So when you suppose like theoretically, try to determine how fast Superman would fly from one set point of the Earth to the other, like how's that? That's something that can't
Yeah,
happen
so
that we
that's not a
don't
part
know
of
to
special
happen.
or general relativity. That's a thing that we know doesn't exist.
Also,
We
that's
don't
just
make
plugging in.
claims that Superman exists, so there's nothing to test. But we
We would
make
still
the
be able
claim that
to map
special
it
and
out
general relativity
mathematically, right?
exists. We make the claim that special and general relativity exist. We make predictions using those frameworks, and then we go out in reality and we test, and those frameworks get the predictions right.
Also,
In the
JD,
framework
like,
of this Superman equation,
wait,
we could
JD,
still map it out, right?
your
We
example
don't
is an analogous.
claim we don't claim Superman as a framework. We claim GR as a framework, and then when we test the framework against experiments, it gets the predictions correct.
This is
If
an
you
even bigger
tried to
problem.
make a framework with Superman and tried to test it, there would be nothing to test. Or,
Yeah,
well, I guess you could come up with predictions, but then what do you test them against?
yeah. Also, JD, like this isn't analogous because one, Superman is just more numbers that are exemplified in the sense that they are really like fast numbers. So the prediction itself lines up with the numbers given, not that the actual character exists. All you're doing is plugging in obscene numbers into established math equations. Like if I were to plug in the weight of like, dude, the gladiator from like the comics, it would work in any equation I give it. Doesn't mean it exists. It just means we can characterize things really well, which is again to our point, not yours. So your example isn't analogous. It just means we can characterize systems with such degree of accuracy.
Do you think you sound smart because you talk smart?
What are you talking about?
So we could use math, but I'm just over exaggerating with my examples, what you're saying.
Can you steal my
Yeah,
one instead real quick?
you're making like a third grade talking point that math is abstract. Yes, math is abstract. We could describe anything we want with math. That's true. The thing is, we're not claiming that every single thing you could possibly describe with math is a thing that exists in reality. We are claiming
Exactly,
that
and
general
that's my
and special.
point.
We are claiming that general and special relativity exist, and then when we test their predictions, they're right. So why would they be getting their predictions right if they're not valid theories?
Well, it's just the fact that general relativity was just founded, or no, the foundation of general relativity was the Lorentz contraction,
That's
and that was
not
based off
the
the
foundation of
Michelson.
it.
That's special.
That's
That's
not the
special.
foundation of it.
That's
That's
special.
not
That's
even
the
Special.
first. That's the first
that
foundation of special relativity,
it's
right?
not. No, the first postulate
Wait,
of special relativity is that the speed of light, or no, that's the second. The first postulate of special relativity is that the laws of physics are the same in every inertial reference frame. The second postulate is that the speed of light is the same in every inertial reference frame. Lorentz contraction and time dilation are results of those two postulates. And this is special relativity, not general.
Think of these
what am I
postulates
thinking
as
of
like
though?
wait, JD. Think of these postulates as more of like axioms, and you can reason through these axioms, and you derive these other principles. It's more so that if we establish this baseline within these equations, consequently these principles fall out of them.
Man,
Right?
I just turned 40 the other day. I wish I was young like this.
And,
Yeah.
and JD, like the way to remember the difference is special relativity is the absence of gravity. General relativity has the G, which you can interpret as like gravity, if it helps you remember.
Yeah. Special relativity is just electromagnetism taken to its logical conclusion.
How about this?
It's basically just combining classical mechanics like Newtonian motion with electrodynamics.
So J
Now,
Mac,
you guys got me on
go ahead, J
Ask
Mac.
an Atheist.
Well, we've obviously taken a diversion tonight because of these guys and their knowledge base. So, what did you want to say, J
Yay,
Mac?
physics.
Where does all this come from? Like, where does light come from? Where does
The ether. It's just a disturbance in the ether.
Life is a result
The
of
ether was definitively disproven.
life is a result of the laws of physics. We find that the atoms and the energy, the way it's set up, and electromagnetism result ultimately in life.
where they come from though?
Yeah, it would just
We
be from
don't
pre-body
know.
chemistry.
We currently don't know, and you guys correct me if I'm wrong on this. We currently don't know why our universe has the values of the physical laws that it does.
Like,
Yeah, string theorists are
why
trying
is
to
there
come
light?
up with
Why is
like
there
a
anything?
framework.
Yeah, so like a fine-tuning issue is like a problem physicists also use. It's like
It's a
arguments
great
against
I
string
am.
theories.
I know the answer. Good luck, guys.
I mean,
Go ahead,
if you're
J Mac.
okay, I was gonna
Oh
answer his
shoot.
question. I was gonna answer his question for him.
Yeah.
I was gonna say, like, you can say life comes from some sort of prebiotic chemistry, which is the foundational to abiogenesis.
Here's
Do
the
you
thing,
guys
J
subscribe
Mac.
to?
Here's the thing I want to say to J Mac. You don't know. You have an idea. You have been taught something, and it is a hypothesis about where something came from. And in your case, I'm assuming you're going to say God, but it's not something that you know. It is something that you believe.
Oh, tinfoil, I just want to make a quick comment. Tinfoil, you're
Mhm.
gonna laugh at me for this. I've been spending the last several hours completely fucking up this problem. I'm supposed to use the 4 momentum of a photon in the reference frame of O and O prime. And then U sub mu is the 4 velocity between those two reference frames. I'm supposed to use the invariance of the product U sub mu, P sub mu to rederive the formula for the Doppler effect. I have been using U sub mu as the 4 velocity of the photon rather than between the reference frames for the past like 4 hours, wondering why it would not work. Jesus Christ.
Should I sound like an ass and say rookie mistake? I have no idea.
Yeah, so like
You're like, I know
if,
some of those words.
if I'm remembering correctly, you can derive this from the formal momentum by defining the forward momentum of like a photon traveling in Minkowski space, right? And
Yeah,
then
I
you
mean,
you
this is
consider
a
the observers.
this is a classical electromagnetism
Oh,
without
okay,
taking
okay.
into account any GR effects. So I'm just doing Lorentz type stuff, but using 4 vectors rather than trying to do it like geometrically and stuff.
Hey,
4 vectors
JD,
are a lot more convenient.
Hey, JD, that's what Lorentz did. Believe it or
Yeah,
not.
you want to learn about 4 vectors? 4 vectors are confusing.
It's actually
I
Max's.
just talked about the 3 wobbles, but that's about where as far as I go with all that.
Why?
Because it's a question you guys can't answer.
Varius gave you multiple answers to it.
Yeah.
Oh, he didn't. That's what
So
you guys
it
say.
was It was nutation. It was the precession of the equinox. So those are
Nope.
two different.
The other one.
Yeah. So those are.
It's the
Yeah.
Chandler
Let me
wobble.
explain one at a time. Those are two different precessions that are happening along the same axis. So it's at two different time scales. Here, let me draw a little diagram. It'll make it a lot easier. So we've got one precession that is happening, let's say like that.
Can you use a
you
black
know?
marker, go? Can you use a black
Sure.
marker?
Yeah, fair enough. The red is a bit hard to see. Okay. So we've got some precession that is happening like that. It's over a very long time scale. You know, this is measuring like the angle that it's at, you know. So starting here, the angle is 0. Starting there, the angle is, let's say, 45 degrees. Here it's 0 again. Here it's negative 45. So this graph is describing it just doing this, just wobbling back and forth. I don't remember if this is nutation or the precession of the equinox, but
Just
it's one
start
of them.
there. That's the
And
biggest
this
wave you got, huh?
and this is time, this axis. The other one, so the other one it's describing is more of like this. You know, it's a much higher frequency event. But what's actually happening, you know, nutation describes one of them. The precession of the equinox describes the other one. The total effect is the addition of them,
Can you?
where we're
Yeah.
seeing this happening, where that angle, you know, if we start at 0, it's wanting to precess positively, but it's doing this. It's until it reaches that 45 degrees, and then it starts going back, but it's wobbling. And then it passes 0, goes to 45 in this direction, and then it starts going back until it wobbles to 0, and then wobbles.
18.6 years, in contrast to 26,000 years. So
Yeah,
that's
so
like faster,
the
isn't it?
distance between these peaks would be that short one. The distance between the much longer peaks would be that much larger timescale one. But this is the same axis. It's not two different axes.
I know that's
You know,
the
like
point. It's on the same axis, so you can't say that it's having its wobbles in rigid space. It's not going to have to. It's all according to the precession of the movement of the axis. So
yeah.
you're
What's the
implying
issue with that?
you're applying two different rotations on the same axis at different rates.
Yeah,
So
it's two different things
so it's
happening.
not
Well, like a net
this
effect.
isn't analogous to like an actual physical representation. And I get why you write it like this because it's tactfully deceiving, but you can't just put it like on a ball, can you? And then just say it's the same thing.
What do you mean?
If the
This
axis
the
is
graphs. The
moving
graphs is just me
slowly,
demonstrating, like, trying to give a geometric representation to help understand what the claim is.
no. So if the axis is moving slowly back and forth, and if you apply a different wobble to that at a significantly different rate, it's going to have to spin up on the same axis. So it can't be on that
What do you mean?
axis anymore. It's going at that rate. It can't move back and forth like that as slowly as 26,000 years. It would have to speed up to 18.6 years in its precession, in its full rotation. And then we have the
There's a
Chandler
lot of different
wobble.
forces acting on the Earth. It's not just the only thing in the universe. You know, there's the sun, there's the moon, there's Jupiter, there's the whole Milky Way.
Yeah, that's fine,
There's
but
many
that's
things
a
that are
non
all giving
sequitur.
little
And if I
tugs.
might add, that's a red herring because it has nothing to do with this one axis.
It does. Gravity, like from each of these objects, is pulling on it in different ways, causing different effects. There's also like the convection currents within the mantle of the Earth that, like, due to like conservation of momentum, as the as a convection current comes up and hits the crust, there's gonna be a transfer of momentum there that has effects on like the rotation and precession of the Earth.
What I'm saying is that these precessions are superimposed on the same axis. So it doesn't have anything to do with external. You could just say that anything can contribute to these wobbles, but then you'd have to superimpose on the same axis. You'd have a problem
What's the problem?
because one's moving faster, one's moving slower, and one's moving much, much, much slower. 433 days, that's a Chandler wobble.
Right. So what is the actual problem?
So if I wave my finger back and forth like no, right? And then I say I want to say to like somebody who's like, you know, having a more serious issue going on, it's a more immediate. I'm gonna want to wave it faster, right? Just you know, if culturally different, due to cultural differences, right? I'm gonna wave it faster, right? I'm gonna say no, but that can't happen. Saying that, I'm also saying no to the other kid. I'm gonna have to speak to those kids individually, and then if I'm gonna say no to the other kid super fast, because that's the only way he'll like, interpret it. Like let's say he's an alien little kid, then I'd have to do the 433-day Chandler wobble, and then I'm gonna have to just vibrate my finger, but that's not the same as just waving my finger.
Yeah,
Like
and what is the actual
no,
problem? Why can this not happen in reality? You're not describing a problem.
because it's all happening on one finger.
Right.
I can't.
So, as I demonstrated with the marker, we can show, like, I showed you an example of, like, what that type of motion is. So, like, I don't see the issue.
That breaks the law of non-contradiction.
Where's the
That
P and not P?
breaks.
Wait, where's the P and not P?
Yeah, because we're saying that one thing is going this speed and it's processing at this speed on the Earth's axis. Its tilt is moving at this speed, right? But then we're also saying this other tilt is moving at this speed on the same tilt. So that's contradictory. That's
Those
a
aren't mutually
physical.
exclusive propositions. As Arius just explained to you, those aren't mutually exclusive propositions.
Mutually exclusive. I'm trying to wrap my head around that in this because it seems like you're not really
Those
understanding that they're on the
thingies
same
can
axis.
God.
those thingies can coexist together, as Varius described to you.
It can.
Wait, so
So
what was wrong with her explanation?
no, because you have this wave that's going very slowly, right? And you need that wave to match up with another wave that's going much faster. And we're
Wait, no,
talking
no,
about waves.
I
We're
get
talking
your
about
problem.
waves
Wait,
because we're not
JD,
talking about.
I get your problem, JD. Like, what was wrong with Varius's explanation of what they gave you? Like
Because
specifically.
it's not anywhere analogous to a physical representation.
Why?
You mean you
Like I
want me
said,
to show you, like, a
yeah,
system that is doing
try.
exactly what we claim the Earth is doing?
Yeah.
Yeah, so
Sure.
go to a playground and go to like what are those spinning wheels called, dude? Like
The merry-go-round?
yeah, merry-go-round and push it less than dude, I did math on this but I forgot. It's a really like weak
Yeah.
push and just push it once every day. And then you will push Earth speed.
All right, so we've got a
That makes no
globe,
sense.
and it's wobbling this way, and now it's wobbling back to center, and it's wobbling to the left, and it wobbles back to center. Like, what do you want to see?
I want to see that, bro. That was
Yeah,
hilarious.
so you want to see that? I just showed you that.
No, you failed,
Like,
bro.
like, what do you want to see? Describe
Okay, so
precisely what you want
it's
me to show you, because you're being very ambiguous.
No, here, get the globe again, right? Get the globe. Let's see in your hand, right? And just tilt it in your hand. Spin it. That's the tilt that we're familiar with. That's the precession of the equinox. Yeah, just spin it. It's already on a tilt. You don't even have to tilt it. This is your claim,
Right.
right? Now we have another wobble. If it's in the same direction, it's going to have to wobble at a slower rate than 26,000 years, right? So if it's going to be on the
Yeah,
same axis, how can you superimpose that motion on the same axis?
I just showed you. It's like it's wobbling like this until it eventually reaches left, and then it wobbles until it reaches right,
No, they
and
have
then
to
it,
do full rotations.
yeah. So it's
No, not yeah.
spinning, and then it wobbles left, and then it wobbles right. Like what? What do you want
No,
to
you
see?
have to 26,000 years for one rotation, right? 18.6 years for another rotation. On the same axis, fine, and in the same
I
direction. You
don't
guys
think
have to have it
you
in the same
understand
direction.
what I'm asking you.
You can't
What
make
do
sense
you
of
want me
this,
to
and you
show
can't physically
you?
represent this.
I
So you're
just
grasping at
showed you
straws.
how it can have two different precessions along the same axis.
You shaking it isn't anywhere analogous to the time frame of 26,000 years and 18.6 years,
So you
and
want to sit here
it's
for
all happening
26,000
on the
years then?
same axis.
You want to
You
sit
we could
here for
scale
26,000
it down
years
with
while I show
time,
you?
try as you might, but it's on the same axis, brother. You can't do
Yeah,
that.
I just did it along the same axis. That was along the same axis
For
at two different
Ayo,
timescales.
Ayo, just for everyone to see, put the third wobble in there. Shake it in
Yeah,
your
those are
hand.
in different directions.
Wait, JD, like, funny enough, Varius's explanation isn't even scaled down, so it actually moves slower than that, which is
Yeah.
even
Oh,
funnier.
actually, you want to see the real-time speed that the globe is spinning?
Yeah, so JD, like, their explanation is like much better than what you asked because they are giving you the benefit of the doubt.
This is how fast the Earth is spinning.
Makes you guys are just feigning confidence, and you guys are
This is
just
exactly how fast it's spinning. Actually, I'm probably going a little too fast.
Yeah, so JD, they are giving you the
It
benefit of the
takes
doubt.
24 hours for one rotation.
Oh, your mic got a little crispy.
All right, guys. I think it's time to let this thing go
I think so.
and move on.
Flat Earth is really slow.
Oh,
Yeah, I mean that's how you know you guys lost, right? We
my
either have
internet cut
meth
out for a
globe
second.
JD,
spinning really fast in one hand,
it's not
All right.
it's not
or
spinning really fast at all, JD. It's really slow.
we
It's
have like
it's
you know
0.0065
insults
RPMs, JD.
and laughs, trying to get rid of your anxiety through laughter, and then feigning
JD,
confidence, like, oh, we
JD,
know this, we've been knowing
this is
this.
really like
And and then
accumulative.
there's the whole host dropping JD thing, you know.
Oh yeah.
That's been enough. It's been enough.
JD is low tier flat earthers.
None of these are good points. It's just you not understanding.
Yeah.
You try to explain, and then you respond in a way that's not even remotely addressing
Yeah.
the point we made or the question we asked.
I'm trying to get
I
myself
don't
back
think
up
he's
on screen. And I
actually
can't pull that.
engaged with the single statement we
Yeah,
made.
it's hard for me to tell if he's not understanding you at all or just not listening, because that is the traditional thing, is to just ignore what's being said to you and repeat back the same line that you came in the room with. So here we go.
I think it's funny that he didn't even realize that wasn't even the scale.
Yeah, but I mean, I give him kudos for at least what he knew. So because he was able to keep up with you guys. Let's let Ralph in for a little bit here.
Brother JD, come on. They explained it to you.
My my best guess from what it seemed to me his misconception is that the wobble, the smaller wobble, can't exist on the same axis if you assume that the smaller wobble is going the full range that the bigger wobble is going. So yeah, you couldn't have two things existing that are doing, like, the Earth couldn't rotate a full circle in 26,000 years and in 18.5 years at the same time. It's got to be one or the other. It seems to me he's missing the point that the smaller wobble exists simultaneously with the larger.
Yeah,
I see.
they're
Yeah.
just at two different like amplitudes.
Right. And it's different things you're observing that they exist on the same axis. But if you look at the scale of, like, if you're talking about the Earth's rotation itself, like, you couldn't have the Earth rotate at one rotation every 26,000 years and one rotation every 18.5 years. Well, no, that doesn't work in that regard, because you're going the full scale on both. And yeah, but he just wouldn't use his brain, or refuses to, or knows it's not true and just won't accept reality, whatever it is. I don't know. I'm vastly confused by flat earthers.
And flat earthers are vastly confused by almost everything.
Hey, JD wants back in. JD, your night's done. So, but I thank you for being in. But we're not going to go through it another hour. We've had a full evening of it, and I think that's enough for tonight. So, guys, thank you for this evening. It's been fascinating. Oh, Londo.
It's been interesting.
Yeah, I just wanted to give you an opportunity. Is there anything you wanted to bring up?
No, I'm just listening, and a lot of it, some of it went over my head.
Yeah,
Uh,
me too.
some of it, the other guy, when it seemed like he was a flat earther, it just, I don't know,
He is. I've interacted with him before.
Yeah. Well,
I don't know.
When there's experts in the room, I gotta step back and let them do the discussion. So, Various, I appreciate you.
Yeah, no problem. Feel free to send me an invite anytime you've got theist nonsense trying to use physics to prove God. I'm actually going to be doing a summer internship at CERN, and I hope to do a lot of lives there.
Wow, that's great. That's great.
I am really excited.
That. Yeah, I appreciate that.
I just think that for somebody to be a flat earther, they also have to realize that all the astronauts, all NASA, like everything, like all the things that are involved in showing that the Earth is not flat, all have to be lies. Like, it just, the amount
Yeah.
of just like your logic you have to set aside is just baffling.
Yeah, like they fundamentally have to believe that either every single expert across hundreds of fields is either lying or doesn't actually understand their field. Like, I am trying to dumb these concepts down as much as I can for him to where I'm actually leaving out information and can't actually explain like the full truth of the situation, because like he can't even grasp like basic high school level physics, so I'm not gonna go into the math and try to explain inner products of four vectors and all that nonsense.
I just don't understand. These people just don't understand like flying, because flying involves understand the curvature of the Earth. Like, it just doesn't make sense.
Yeah. I mean, none of the big conspiracy theories make sense because of the same thing you said there. Like, the number of people that would be involved, like the people who think that vaccines are all a hoax perpetrated by a couple of pharmaceutical companies and stuff, and meanwhile ignoring the fact that it's not just the U.S., it's not just the CDC, it's not just a couple of drug companies, it's every CDC or whatever equivalent in every nation around the globe.
Yeah.
The number of people that would need to be paid off by the drug companies is astronomical.
Well,
And again,
paranoia is inherently
Yeah.
illogical. So, what are you gonna do?
Yeah, I guess that's where like you have to make sure you've the fine line between skepticism and just total conspiracy tinfoil hat.
Yeah.
And that's the
Right,
thing.
just denial. There's a difference between I'm skeptical, I'm going to question this and see if it holds up to scrutiny, versus just la 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 nah. Like,
Yeah. Yeah. And the whole idea of not accepting scientific consensus to me is something that really bothers me when people say they want to get homeschooled so they can learn the religion part of it and the true things about evolution. I don't know if you were here to hear the very first caller. She was off the charts in every direction you could possibly imagine. I'm gonna have to post that later on. That was quite something. I didn't hardly even know what to say to her.
I did not. Before I came on, that would be great to be able to. Yeah.
Yeah, that was something. All the way from evolution is not true to women should be doing what their husbands tell them to, and they are inherently inferior in some ways of decision making and this and that. And it's like, oh my gosh.
But again, the whole thing, evolution is not true. It's the same thing as the flat earthers. It just,
Yeah.
to me, it's just like, what?
Yeah.
Like, why did you not pick up like, have you not studied? Like, again, you can't say it's not true.
Well, that girl in particular, she was Mormon, and she grew up in that household, and probably her entire community culture from the sounds of it, because she was 100% in
Absolutely.
on everything.
Absolutely every single Exmo I've ever met has immediately told me it's a cult.
Yeah.
Well,
I mean,
that
I
tells
think,
you a lot.
I think every religion is a cult to some degree, but boy, Mormonism or LDS, they want us to call it LDS now. I call it Mormonism because I think calling it LDS is a marketing campaign to try to get away from some of their bad history. All right, boys.
JD saying I lost. That's funny.
Let him have his fun.
Okay.
Let him have
Think
his
whatever
fun.
you want.
Let him have his fun. I
Yeah.
appreciate it. I'm going to wrap up and
right.
get a little bit of other work in. It's been a
Have a good night.
fascinating evening listening to you guys, and I appreciate your knowledge so much. I can't tell you. So.
Yeah, no problem.
No problem.
Take care, Ralph. Take care, Londo.
Bye.
See ya.
Everybody out there, be kind to each other. Till next time. Take care.